In this video, we're going to discuss how to evaluate a limit from a table. So a quick review of what a limit is. So the notation looks like this. We have the LIM part, which represents that we're doing a limit. Our x values are getting close to some number a, and we'll kind of know what that number is when we're trying to evaluate. And we're looking for our y values to get close to this number b. And of course, this is just whatever function we're talking about. So those are the parts of our limit notation. We're doing a limit. Our x value should get very, very close to this a value. And at the same time, our y value should be getting very close to that b value. And that's how we know the limit is that value b. All right, so consider this table. I'm going to write a limit expression for the stuff that we can see. So of course, this isn't a full function, but we have a kind of snapshot of values. So we need to ask ourselves two questions. What is x going to? And what is y going to at that x value? So generally what happens with these tables is the kind of middle is where you're focusing, because your x values are going to kind of come from both directions to the point you actually care about. So if we think about a number line, right, on this number line we have 1.9, 1.99 is more than that, 1.999 is a little bit more than that, 2.01 is more than that, 2.1 is more than that, or 2.01 and 2.1 is more than that. So you can see right in the middle here, they're all kind of converging to the same place. And what's between 1.99 and 2.01? That's going to be 2. So 2 is kind of right in the middle here. That's where our x values are getting close to. And then what are our y values getting close to? Again, we're kind of focused on the middle here. But in this example, everything is 5. So our y value is always just 5. So our y value is just getting close to 5. And so as our x values get closer and closer to 2, our y values are getting closer and closer to 5, and that means we can write this limit expression. So the limit as x gets close to 2 of f of x is the y value 5. So as x gets close to 2, our y value gets close to 5. All right, in this next example, trying to do the same thing. All right, the table is just a little bit more complicated, but again, we're looking at where are our x values getting close to, and then at that point, what are our y values getting close to? The first thing I see is kind of when the decimals get smaller, that means you're getting closer and closer to numbers. So again, most of the time, you're kind of looking right in the middle of your table, and these numbers are working up towards the numbers. These numbers are kind of going down towards the numbers, and you see at the middle here, we're going to be at 3.5 is in the middle of that table. So that's where our x values are getting close to. And then what are our y values doing? -1 to -0.3 to -0.002. That's going to a really small number. And as we're working our way towards this middle line, these positive numbers are getting smaller and smaller. And what's in the middle of these negative and positive numbers? That's going to be 0. So as our x values in the middle are getting close to 3.5, our y values are getting closer and closer to 0. So our limit x is getting close to 3.5 of g of x. That's the name of our function. And that's going to be 0. So as my x values get close to 3.5, my y values get close to 0. All right, one more example. Again, same thing. We're focusing kind of in the middle of our, it's not always going to be exactly the middle of these all examples are, but you're kind of focused in the middle because things are kind of trying to go from both directions towards your value. So it doesn't make sense for it to happen on the sides. All right, so we're looking in the middle, and what are x values getting close to? They're getting close to 8, right? So think about what are those values both really close to. And then our y values here, -1, -1.99, -1.999. That's basically the same as -2. From here, 1, 1.9, 1.99. That's basically the same as +2. And we've seen examples like this before. All right, our x values are getting close to 8, but our y values are getting close to -2 and +2. And it's not possible for my y values to get close to two different things. So I'm going to say for my limit in this case, my limit as x approaches 8, that's going to not exist. So we say D and E does not exist because our y values are getting close to two different values at the same time. All right, so here's something for you to try on your own to see if you kind of understand what's going on with these tables. So instead of starting with the table and writing the limit, here I give you the limit and you want to create a table that makes sense. So you want your x value to be getting closer to 3, and your y values be getting closer to 10. So go ahead and try to do that on your own, and I'll make it my own. Everyone can be a little bit different, but some things should be the same. So go ahead and try that one, and I'll show you my solution in 3, 2, 1. So here's one example of an infinite number of examples, but I want my x values to get close to 3 and my y values to get close to 10. So the first things I put on my table are these black values in the middle. All right, so I'm thinking again, the middle is right here. Just to the left for that x value, I just want to be a little bit less than the x value I want to be close to. So a little bit less than 3 would be like 2.99. Just on the right of that, I want to be a little bit more than 3, so 3.01. And I did the same thing for the y values. I know my y values want to be close to 10. So on the left, I can be a little bit less than 10. You can go the opposite direction for y's. I could have put 10.01 here, 9.99 here. All right, but just a number close to 10 on the left, number close to 10 on the right. And then just generally as you work away from the middle, the difference from that place is going to get a bit bigger. So now instead of 3.01, I go to the red number, a little bit bigger, 3.1, and the blue number a little bit bigger, 3.4. Going to the left, my x values are getting smaller on the number line. So 2.99 is going to become 2.9, 2.9 a little bit smaller, 2.7. Right. And then doing the same thing with the y values, just getting kind of farther away from that 10 as I move to the side. But the most important thing is right in the middle here, all the numbers should be close to 3 in your x place and should be close to 10 in your y place. All right, so a quick summary of what we learned. Make sure the x values are closing in on a number, figure out where those x values are kind of zeroing in on as the decimals get smaller. Normally happens in the middle of your table. All right, at that point, make sure the y values are closing in on a single number. We saw one example where there's two different numbers, -2 and 2. That's when your limit doesn't exist. So figure out what that number for the y values is. And if both those things are happening, then you can write your limit. All right, so that's how you evaluate a limit from a table.